Hello everyone and welcome back to my channel.
On Monday, the 8th of April, millions of people across North America are set to witness one of the rarest of treats, a total solar eclipse. From the Pacific coastal city of Mazatlan in Mexico to the eastern coast of Canada's Newfoundland, the moon will perfectly block the sun and cast its shadow on the ground, turning day to near night. But it's not just the public set to be enthralled, as scientists race to prepare experiments to observe this magnificent event. Every 18 months, a total solar eclipse occurs somewhere on Earth, a fortuitous quirk of the sun being 400 times further from Earth than the moon and 400 times larger, making the disk of the moon entirely cover the solar disk when it perfectly aligns between Earth and the sun. This April eclipse is of particular note, however, because of the vast amount of populated land the eclipse will pass over, allowing many millions of people to watch. Locations in the path of totality will be plunged into darkness for no more than 4 minutes, but that is enough to perform some of the rarest of science experiments, with scientists hoping to observe the sun's atmosphere, its corona, as it dances around the moon, the reaction of wildlife to the celestial event, and even launching rockets to observe how Earth's atmosphere reacts. An estimated 31 million people will be in the path of the eclipse, double that of the last total solar eclipse that crossed the U.S. on the 21st of August, 2017. Totality is also longer this time around, up from 2.5 minutes for most observers in 2017, because the moon was further away from Earth. In year 2024, eclipse path will also be almost twice as broad, nearly 200 kilometers wide, whereas in 2017, eclipse path was just 110 kilometers. Adam Hartstone Rose from NC State University in North Carolina is leading a project to study how wildlife reacts to the eclipse. In year 2017, he had teams of researchers stationed at different zoos in the path of totality to watch how animals behaved. Some were baffled. A group of gorillas trooped inside for their evening meal as darkness fell, but were left empty-handed as daylight returned. "The giraffes were my favorite," says Hartstone Rose. "Somebody had reported wild giraffes in Africa started galloping during a total eclipse. I was really skeptical because giraffes are pretty passive animals. Despite my skepticism, some of them started running around." The most crazy behavior, says Hartstone Rose, was a group of Galapagos tortoises. As totality grew, they became more and more active, he says. Right at the peak of totality, they started mating, which we cannot explain. Maybe it was a one-time thing. We're going to be watching more tortoises this time around. Hartstone Rose will have researchers stationed at Fort Worth Zoo in Texas to monitor more than 20 species of animals during the eclipse, including gibbons, flamingos, orangutans, and of course tortoises. Animal behavior studies, either observing pets or nearby wildlife, all animals are of interest, from dogs to farm animals. There's very little information about what farm animals do, says Hartstone Rose. Are cows going to come towards the barn during totality? Animals react to the change in light, sometimes very strongly. Trey Winter Hartstone Rose, who will be studying how animals behave during the eclipse. Trey Winter at the Advanced Research in Inclusion and STEAM Accessibility, ARISA lab in Massachusetts, will lead NASA's Eclipse Soundscapes project, which will be using small phone-sized devices equipped with microphones called audio moths to listen to the sounds of nearby animals. Hundreds of volunteers will place the devices along the path of totality, allowing Winter and his team to hear how different animals react, sometimes very strongly, and also temperature changes, says Winter. It's a multi-sensory experience. A range of animals will be studied, such as crickets and even humans. I'm looking forward to listening to a lot of humans experiencing an eclipse for the first time and the sounds of excitement they make, says Winter. That's something Hartstone Rose is interested in too. The strangest animal behavior we observed in 2017 was the people around us, he says. People started hooting and hollering or lying down on the concrete. As the moon's shadow passes over, it's expected that the density of the ionosphere will drop, reacting to the passing shadow in ripples. It's like a motorboat on a lake, says Barjatia. Flying so high allows for a much more precise measurement of the ionosphere to be made during the eclipse than is possible on the ground. Ground-based observations have a very large resolution. What the rockets help us do is look at sub-meter resolution, sometimes under a centimeter, so you are able to see the smallest level of fluctuations, which create radio frequency interruptions. The hope is that the mega-movie will reveal features of the Sun's corona. On average, any given location on Earth only sees an eclipse once every 375 years, meaning this eclipse will not only be watched, but photographed by many witnessing the historic event. Laura Peticolas at Sonoma State University in California is asking anyone that does so to get involved in her Eclipse megamovie project, which will seek to stitch together hundreds of images from observers into a single movie of totality. Peticolas ran the same project in 2017 but noted it wasn't as beautiful as we were imagining in our minds because of a lack of imagery. So this time around they will be hoping for a much wider pool of images, including better professional images of the eclipse, to produce a more polished product. The hope is that the mega-movie will reveal features of the Sun's corona, such as jet-like ejections of hot plasma firing around the Moon, evolving as different people along the path take images. This time we're really expecting to be able to find those jets and features that are changing, she says. Ordinarily, such events are extremely hard to study except for specially designed telescopes or spacecraft that can block out the Sun, but a total solar eclipse allows many more observers to do so. This event should be particularly noteworthy because the Sun is heading towards its period of peak activity, called solar maximum, that takes place in an 11-year cycle for reasons that are still not fully understood. This is going to be a much bigger eclipse in terms of people heading towards the path of totality, says Peticolas. This project really capitalizes on that. I'm hoping for like 500 volunteers to upload images. For many people on the ground, the weather could play a crucial factor in whether they can actually see totality or not, with cloud cover always threatening to spoil the view of the Sun. One way to avoid that is to take to the skies, something NASA will be doing with two of its WB-57 planes. Flying at 50,000 feet, the planes will follow the path of totality off the coast of Mexico, experiencing about 7 minutes of darkness, and will be equipped with instruments to study the Sun. Leading one of the experiments is Amir Caspi at the Southwest Research Institute in Colorado, who will be using an infrared camera on board one of the planes, although he won't be flying himself, to study the solar corona. One of the key mysteries of the corona is that it reaches millions of degrees in temperature, compared to just 5,000 Celsius for the surface of the Sun, for reasons that can't fully be explained. Caspi thinks there may be a link between ejections of plasma from the Sun, called prominences, essentially a blob of plasma that has bubbled up from the surface, and the corona itself. These prominences are up to 30,000 Celsius, much cooler than the corona, but can emit as brightly in infrared. We're trying to answer what is contributing to this emission, says Caspi. They can't be the same mechanism because of this huge difference in temperature. One answer might lie in how magnetic fields twist and turn above the Sun's surface. If rockets and planes aren't enough, Angela Desjardins at Montana State University will be leading 53 teams of students across the U.S. that will send about 600 balloons into the atmosphere as part of the nationwide Eclipse balloon project. Rising up to 115,000 feet, the balloons will use instruments to see how both Earth's atmosphere and its weather react to the changing conditions of the eclipse. Some of the instruments will study gravity waves, pressure waves moving through the atmosphere as a result of the changing temperature. It's like a rock thrown in a pond and it creates waves, says Desjardins. Others will measure humidity, wind direction, and wind speed to monitor any changes caused by the eclipse. Having 600 balloons that are flying and measuring the atmosphere is such a wonderfully rich data source, says Desjardins. We're expecting at least a dozen papers to be published as a result of the data we collect. There will even be some cameras on board that will live stream the eclipse down to the ground. The expectation this time around is that while the 2017 U.S. total solar eclipse whet the appetite for the public and scientists alike, 2024 will be a much more widely watched and studied event because of the amount of ground it will cover and the knowledge of what to expect this time around. I think people are more excited about this, says Heartstone Rose. 2017 was unexpectedly cool. 2024 is going to be over a more populated part of America, and even more beautiful because the sun is in this amazing cycle of ejection.
Thanks for watching this video, and don't forget to like this video, click on the subscribe button for more update, and let us give your opinion on video in the comments section below.